Polar coordinates. Number one. What in the world are we going to do? Well, we need to figure out the rectangular coordinates. Rectangular coordinates are the x and y values. Polar coordinates are the r and theta values, and I'm going to mention this a little bit later. If you're watching some of the videos, I'm going to say this later. How can you remember what's polar and what's rectangular and all this? Well, polar, P-O-L-A-R. Look, it has a theta and it has an R in it. So there you go. You know that's polar because it has degrees, which tells me that it's an angle measurement. So it's theta, and this one must be R. And it said it was polar. So here goes. First thing I need to do, I'm going to clear out that last problem that I did. I'm not filming these videos in order, in case you're wondering. And because I'm not filming them in order, my calculator might be set differently than yours. But I'm going to press mode. Maybe yours is in degrees, maybe it's not, but I want you to put it in degrees. How do you know? Because you're going to have to do some trig, because you have an angle involved, and that angle is in degrees, so go to degrees. They will not tell you what to do. It'll be buried in the problem. That tiny little symbol right there tells you what to do. Don't forget to do it. Put it in degrees. So what are the approximate rectangular coordinates? We need to know an x and a y, and there were a couple formulas that I gave you, but if you don't remember them, let's think back to the unit circle for just a second, just in case you don't know what I'm just about to write. We had our little unit circle right there, and we had a point on it. This point right here was obviously x comma y, but let's really call it what it was. On the unit circle, it was cosine comma sine. So we know that x is cosine of theta and y is sine of theta, and that's great. That tells us how far to swing around, because that tells us the angle, but it still doesn't tell us the length. Now on the unit circle, the radius is 1, so it wasn't a big deal. But now if we're going to use polar coordinates, we might need to go out further than 1. I said all that to say this. X is r cosine theta, and you can remember the cosine because it's on the unit circle, and y is sine theta, again because of the unit circle, and the r just needs to be put in the front. So let's just do it. R is 5 times the cosine of 30, and this one is 5 times the sine of 30 degrees. And I'm going to do something that I don't have to do, and I could just grab a calculator, but I'm not going to. We know what the cosine of 30 is. Cosine starts with 1 square root 3 over 2. Square root 2 over 2, 1/2 then 0. Sine counts back with 1 square root 3 over 2, square root 2 over 2, 1/2 then 0. Alright, so this will require a calculator here. Actually, I'll go ahead and tell you it's probably not, because we can do 5 times a half, that's 2.5. So the y value is 2.5, that automatically eliminates A, B, and C. The answer is D. And even if you didn't know this unit circle stuff that I just randomly pulled out, you could have typed it in. You could have gone 5 times cosine of 30 in degrees and gotten 4.33. So there we go, 4.33. Or even from this step, 5 times the square root of 3 divided by 2. There we go, 4.33. Same, either way. Same thing here. 5 times the sine of 30 is going to give you 2.5. Answer again is D.